Welcome, everybody. Thanks for joining us today. We're going to get started in just a couple of minutes. Hi, everyone. Thank you for joining us today. We'll get started in a couple of minutes. Good morning, good afternoon, good evening from wherever you are. Welcome. We'll get started in about 1 minute, just waiting for others to file in. Okay, let's go ahead and get started. So welcome to Hyperledger Foundation's In-Depth with Kaleido. We have Nick Gaski here today, who's the Customer Success Manager at Kaleido. He's going to share a lot of really useful, helpful, practical information with you. I hope you all look forward to this session. My name is Karen Otoni. I'm Director of Ecosystem here at Hyperledger, and I'll be the host for today. I'll be monitoring the chat and the Q&A box. So you'll see me jump in here and there. First of all, a few housekeeping items. I want to emphasize that all are welcome here in the Hyperledger community. We hope that you are joining from anywhere and everywhere, and we are here to help make this experience in the Hyperledger community one that is welcoming to you. As with all meetings at Hyperledger, we have an antitrust policy. You can find it on our wiki and on our website. This will be recorded, and any slides shown will also be available on our website. We're also live on YouTube as well, so welcome to everybody who's joining live. We encourage these sessions to be very interactive and engaging, so feel free to post questions in the chat, the Q&A box. If it feels like relevant to what Nick may be discussing at that time, we may even ask you to come off of mute if that's something you want to do and ask your question live as well. So we're here to make this this hour really useful and productive for you. So without further ado, let me introduce Nick. Thanks for joining us today, and we look forward to what you're going to share. Let me just stop sharing. There you go.
Awesome. Thanks so much, Karen, and thanks everyone for attending. Wherever you are in the world, hope everyone is staying safe and staying healthy as we're hopefully nearing the end of this 3-year pandemic. So my name is Nick Gaski. I help lead customer success and client enablement at Kaleido. I've been with Kaleido for a little over 4 years. Prior to that, I was at IBM working on Hyperledger Fabric in the open source community and also with the product offerings for the IBM blockchain platform. So about 6 years of enterprise blockchain experience for me. Let me actually stop sharing real quick. So what I'm going to start with, I'm going to take you guys through Kaleido. I just want everyone to know that what I'm going to be showing you, you guys can actually do this alongside with me. You don't need to be a programmer. You don't need to be a coder. It is like intuitive, as straightforward as it gets. So the only thing you have to do is just create a free Kaleido account. So if you visit kaleido.io, you'll see this try it for free button, and it'll take you about 30 seconds to create an account. And then you can follow alongside me with exactly what I'm doing. So I just want everyone to be aware of that in case you want to put your hands on the keyboard and just press a few buttons. So what's Kaleido? Kaleido is a digital transformation platform. We have blockchain as a service as the beating heart of the network, but we also have a lot of additional components, many of which you'll see as we start getting into the demo. We're built for modern business networks, so we're completely agnostic to specific use cases or industries. And the production projects running on Kaleido really do span the gamut, all the way from government entities to retail and entertainment with, supply chain, healthcare, trade finance, insurance sitting somewhere in the middle. Our platform is radically simple, both for using the graphic user interface, also for developers who want to use APIs. So we put a REST API behind every single piece of functionality, whether that's doing admin CRUD operations or whether it's just talking to the blockchain and issuing transactions. And then the third thing, which is really important for this community, is we're built for the enterprise. So, really hardened constructs like high availability, disaster recovery, enterprise key management, et cetera. Those are all either built in as first-class citizens or they're pluggable or integratable components. So Kaleido, we offer a breadth of different blockchain orchestrations. So we can see down here at the bottom that we have a number of Hyperledger projects sort of under our umbrella. So we support Hyperledger Fabric, Hyperledger Besu, additional Ethereum variants like Quorum and Geth, alongside R3 Corda. One thing that makes Kaleido really unique is we don't pigeonhole you into a specific protocol or a specific cloud or even a specific region. So the orchestrations are as flexible and configurable as you want. You can create multiple blockchain environments across different protocols. You can have your nodes running in AWS and in Azure, or you could have a super hybrid orchestration with one node in AWS, one node in Azure, and maybe another node running on-premise, behind your DMZ. What we've noticed, and we'll get into kind of what I mean by full stack blockchain, but over the last 6 years working with these myriad different customers, we've seen that blockchain is incredibly important, right? Everyone on this call knows that, but it's a really small fraction of the overall piece that you need when you build an app. There's tons of additional components. You want to integrate with your back office systems that you've made big investments with. You need APIs, you need interfaces, you need questions and answers around privacy, around encrypted data. And you need to be able to deal with, in Ethereum, things like digital assets or maybe even sort of bleeding edge constructs like zero knowledge proofs. So all of these features are encapsulated inside of Kaleido, again, either as a first-class citizen or as a very easily pluggable component. Last thing, I touched on sort of enterprise grade, but this kind of speaks it into life. We have great security certifications, ISO 27K, SOC 2 Type 2, really cool key management constructs like keeping your private keys in a cloud HSM, for example, and then all those other things, HA, DR, answers for business continuity or running your blockchain nodes or other processes on premise or in your own private cloud. So that's it for the slides. I promise this will be all interactive from this point on. So let's go ahead and hop into Kaleido. So the first thing we're going to do is we're going to go ahead and create a business network. We're going to create a fictitious consortium here, right? And so I'll just call this example business consortium. And the first thing we'll be asked to do is select a home region. This is Kaleido saying, I need you to whitelist a specific cloud and a specific underlying region so that you can deploy nodes and deploy services into this availability zone right here. So I'll choose AWS in the States, since that's where we're located on the East Coast. But now I see the option to bring on additional regions or even additional clouds. So I could turn this into a multi-region, multi-cloud network and accommodate for a very diverse consortia. Not everyone uses AWS, not everyone uses Azure, not everyone uses AWS or Azure, right? Hence private stack and hence all of the integrations that we provide. I'll keep it simple and just use AWS in the States today, but it's that easy to sort of onboard and whitelist additional clouds in additional regions. So boom, there's a namespace for our business network, and we can choose to expand this business network in one of two ways. So my organization, Org ABC, is attributed the first membership inside of this business network. And for early stage projects or for sort of a proxy operating approach, what we've seen as a useful technique is just creating multiple membership objects, right? So you can mock out how your network is ultimately going to look, or you can create a membership for another participant, and you can be, quote unquote, a benevolent dictator, and you can operate those resources on their behalf. Once you've hardened out the topology, hardened your source code, your application tiers looking good, then you can actually decentralize your network. You can bring on additional organizations that have their own Kaleido accounts to own and operate, their own Kaleido resources autonomously under their own control. So we'll say example, external organization, admin@email.com. And now Kaleido is going to allow you to implement role-based access control. So when you found a network and you onboard another participant, you have the ability to choose what they can do or what they can't do. Should they be able to create Besu nodes that are validators? Should they be able to onboard other participants? Should they be able to manage your blockchain environments and upgrade the releases and the versions? All right, so you can allocate and rescind these permissions as you see fit. Right, so we'll offload that invitation and boom, we've done all of our housekeeping at the network level. Now, if we drill down a level underneath our network, we have a construct called environments. And in Kaleido, you can have many, many, many environments, right? So I talked about being able to have a Fabric environment, a Besu environment, a Corda environment, et cetera. And so this allows you for very, very high-speed experimentation, iteration, and also allows you to create a very elegant, very logical DevOps pipeline. So let's go ahead and create an environment now. So we see two doors to go through. I'm going to come back to FireFly, but at a high level, FireFly is an orchestration layer that encapsulates a lot of the features that I'm going to show you: REST APIs, events, tokens, encrypted private data transfers, etc. So it's just like this macro API that's very, very easy to program against, lets you get data into the blockchain, lets you keep data off of the blockchain, do stuff with digital assets, etc. It's really kind of a I'll use orchestration layer for multi-party systems. So I'm going to just create a standard blockchain service right here. And now Kaleido is asking me, okay, what sort of high-level protocol are we interested in? Do we want to go through the Ethereum door? Do we want to go through the Hyperledger Fabric door? Or do we want to go through the Corda door? And on this webinar, we're going to go through both of these doors today. We're going to take a look at Ethereum and we're going to take a look at Hyperledger Fabric. So let's start by going through the Ethereum door and providing a name for our environment. And as I said, you can have many, many environments, right? So development, sandbox, user acceptance testing, pre-prod, production, etc. I'm going to go with a cloud-only orchestration, but we see there's support for a hybrid orchestration where if I wanted, I could have a node running on my local laptop right here that could securely tunnel and securely connect back to fully hosted nodes. Okay, so we've gone through the Ethereum door, we've chosen a name for our environment. Now Kaleido is saying, okay, now tell me what kind of configuration you want. Choose your node client, your Ethereum variant, and choose a corresponding consensus algorithm. So since this is a Hyperledger webinar, we're of course going to choose the Hyperledger client. And I'm just going to go with Besu and proof of authority, but we also see that IBFT 2.0 is also an option here. There are some advanced settings that you can choose to input here. So you can choose a custom chain ID if you want. You can manipulate the block period. POA defaults to 5 seconds, but you can raise that up to 10 seconds if you want. And every blockchain, every environment actually gets bootstrapped inside of the Genesis block with 1 billion Ether. This is a private permission blockchain, so that Ether has no intrinsic value. But as we'll see here in a second, you can choose to charge gas prices for your transactions, or you could use that Ether as a facsimile of a fungible token, or for just other utility inside of your network. It's there for your convenience more than anything else. So we'll click finish, and now we have the namespace for this Besu POA environment, and we'll go ahead and bring it to life by creating some nodes. So I have 2 memberships, ABC and XYZ. So we'll bind the first node to membership ABC. We'll click next. I could choose to integrate with a bunch of existing cloud services that I have. So maybe I have a KMS instance, or I have an S3 bucket, or I have a CloudWatch logging group, or I have VPCs. All of these things are very, very easy to layer in directly to your runtimes on Kaleido. I'm going to skip those for today. And then the last thing we need to do is just choose the footprint size for our node based on how much throughput our application needs, how much horizontal scale our application needs. And then we just want to choose if this node is going to be a validator or just a replicator. So I'll click finish, and boom, we've brought this blockchain to life. So I'll very quickly go ahead and add another node for our other membership right here. Just call this node 2, and we'll fire through this, click finish. And now we have a 3-node network. I say 3 nodes because in Kaleido, you actually get a free validator by default. You have a system monitor node that's going to do all of this rich indexing. It's going to expose data and metrics so that we can dive deeper, into transactions, into smart contracts, into, rich block information. So we'll give these guys a few seconds to come up. And while they're coming up, let's take a look at how we're going to teach Kaleido about a smart contract. So I'll scroll over to some slides here. So we have a service called Smart Contract Management. And again, this is going to fit directly in with your existing change management systems, whether you sort of have a local orchestration, whether you're using, GitHub, for example. Kaleido will allow you to import your source code however you want. You can go from a private GitHub, public GitHub. You can go directly from your machine with a, Solidity file, or even if you want, you can actually compile the code and just give us the bytecode and the binary interface. The takeaway is that once you've done this, your entire network will have line of sight into the business logic, into the smart contract that's being executed. But the real valuable thing is that as soon as you teach Kaleido about a smart contract, we will expose REST APIs for all of those exercisable methods inside of the Solidity, right? So we don't need to use SDKs like Web3 JavaScript or Ethers or Nethereum anymore. We just do basic web development here, and we can fire in, async JSON payloads. And Kaleido will do all of the translation to turn that into a properly signed and sequenced Ethereum transaction object. We have Apache Kafka as the message bus, so you get reliable delivery into the system. It's just a really straightforward, kind of easy interface to, send transactions into the network without having to become an Ethereum or blockchain expert. So let's dive back into Kaleido. We can see that our nodes are joining and coming up. So as those are fully initializing, I'll go ahead and show you how to create a smart contract project. So we're going to go up to our business network view. We're going to click on the apps right here, and we're going to create an Ethereum app. So I'm going to call this simple storage. And I'm just going to import this source code from GitHub right here. And we'll see how easy this is to do on Kaleido. So I've created the namespace for this application project. It's not really interesting. All I've said is it's Ethereum, and it's going to be coming from GitHub. So what I need to do now is I actually need to create a compilation, a new version of this source code, right? And Kaleido is asking me, okay, well, where is the source code? You said this is coming from GitHub. I need the URL now. So let's go ahead and give Kaleido the URL. And we're going to give it a very trivial smart contract. We'll do some stuff with tokens here in a second, which is a bit more interesting. But this is a very basic contract that makes it, really easy to make sense of these REST APIs. So it has a single invocable method called set right here, which will change the state of this global variable stored data to some positive integer that's less than 100. That's about it. And then there's a couple getters, a get and a query right here to say, hey, what's the current world state of this variable? So let's grab this URL and let's go ahead and import it into Kaleido. And Kaleido will do all of the other auto detecting of the Sol C of your, sort of Ethereum versioning as well. So as this is compiling, let's hop back to our environment, make sure that everyone has come up and started. We see the monitor and both nodes are up and running, so that's good. So as soon as this thing has properly compiled, we can go and promote this source code into the environment. So we can go back here, give this a few more seconds to compile, and then we can go ahead and teach our Kaleido environment that I named development about these available APIs right here. And when this actually does completely finish, what we'll see is we'll see the bytecode and we'll see that ABI, that binary interface. And this is really what Kaleido needs to expose those REST APIs right here. And so we can see how easy this would be to, say, hey, here's sort of like where we're doing our change management. I want to iterate on this smart contract logic, and I want to upload, a new version with, an additional object or an additional, variable inside of it, or an additional method. Becomes really, really easy to kind of, promote these up into Kaleido, push them into your dev or staging environment, make sure they're working. Once it's hardened, you can go straight into production without changing your code. So I'll promote this into that environment. I'll choose a name for the APIs, call them SS, and just click finish right here. And what this does is this gives this development environment that I've created a definition of the REST APIs inside of that simple storage smart contract. I will have an open API interface that's accessible, that's exercisable inside of this environment that I can use to speak to the blockchain genuinely. So we will simply just deploy this smart contract, and then I'll hop into an environment with a lot more going on. So let's go ahead and view this API. We're viewing it through the interface on node number 1. And the other cool thing I guess I should mention is that, when you promote this source code to the environment, every single node gets taught about these APIs. So you don't need to transfer source code out of band. You don't need to upload, any binaries or any files, by yourself. As soon as one participant in the network pushes some smart contract logic, every single participant, every single node has its own unique accessible interface to speak to it. So let's give this a quick refresh right here. And let's go ahead and view these APIs. Okay. So this will expose a exercisable Swagger interface inside of the console. And what I'll be able to do, going a little slowly, what I'll be able to do is I'll be able to just call the available root post method, and I'll be able to use that to deploy this smart contract if this comes up today. Okay, here we go. Sorry for the slowness. Okay, so we're going to take this root post method, and what we'll see is I'm doing this inside of Kaleido, but everything I'm doing you can very, very easily do programmatically, right? So here's the request URL that we would be posting to deploy this smart contract, and we just need to give it an initial value to that constructor, right? So I'll give it 123 right here. And then we have another query parameter. So we have the query parameter that says, hey, this is the address that's going to sign the smart contract. This is the default account on node number 1 that I'm viewing this API through. But then we have another parameter here that says, hey, do you want to apply like a human-friendly name to this smart contract versus dealing with hexadecimal strings? And yeah, of course we do. So I'll call this SS123. We can go ahead and execute that. And this will be our first actual blockchain transaction. This will be an instantiation of this source code, and this will be a deployment into the network. And what we'll notice when this actually finishes, this is a synchronous call, so it's waiting for it to execute before it returns the receipt, is that we're going to have an instance. So we had a gateway, we had a definition of this smart contract, which was these APIs, but now we're going to have a specific instance, right? We're going to have a smart contract endpoint that we can actually call. Again, going a little slowly today, so I'm going to do a quick refresh, and we'll hop out of this environment and go into a different one. But the idea is that okay, so let's hop into the different environment. I've already done this in another one. So let's go here, go to smart contracts, go to simple storage, and we see that I've deployed an instance onto the blockchain right here. So rather than calling, this full hexadecimal string right here, which is a basic Ethereum smart contract address, we can use the Kaleido REST APIs, and we can just call this convenient endpoint right here, SS123. Okay, so let's go ahead and invoke this real quick. So we can view this instance API. We'll view it through node number 1 right here. Looks like this environment is going way faster, which is awesome. So let's go ahead and call this set method right here, and we'll just change the existing value to 99 right here. Again, signing with this identity on node number 1, submitting the transaction synchronously, and we can just go ahead and click execute. So we'll do this, and I'll take you into Postman, and we'll get a little closer to how this would be done programmatically right here, okay? So that's how easy it is to use inside of Kaleido, right? Just point to a URL. It could be OpenZeppelin. It could be your local GitHub fork. It could be, whatever Solidity that you care about, whether it's on your machine or in GitHub. If it compiles, we will expose REST APIs for you. So just making life easy for developers to speak to these endpoints right here. Okay, so let's talk to it from Postman now. So we can go into a Postman terminal, and we can go ahead and say, hey, what's the current status of this smart contract right here, right? So what we want to do is we want to call instances, SS123, and then we can just call this query method right here. Okay, so we can do a quick query, and we should get back a value of 99, which we just upserted. Okay, so very straightforward there. Every endpoint in Kaleido, conscious I'm giving everyone a lot of information, but the platform is very rich, has a lot of functionality and sophistication. Every ingress, every endpoint in Kaleido has boundary security. So if you're programmatically, speaking to your node or trying to call a service endpoint, like IPFS, for example, those calls are protected over TLS. So you need strongly generated, username, password, credentials, and passed over basic auth. And those are accessible inside of the security tab inside of your environment right here. You can cycle these however often as you want, right? Make them as short-lived credentials, or they can be static, long-lived credentials as well. Okay, so pressing forward. Now let's go ahead and use Postman, use these programmatic APIs to change the value. So let's change it from 99 to 98, for example. Okay. And the other parameter that we want to look at, the query parameter, is this thing called KLD sync, right? X-Kaleido sync. So that's us telling Kaleido, hey, I want you to wait for this transaction to actually get executed before you return me the transaction receipt. Well, that doesn't make a whole lot of sense in high throughput scenarios, right? We need to send thousands or tens of thousands or hundreds of thousands of transactions into the network. It's not tenable for us to wait 5, 10, 11 seconds for that receipt to come back. So we support firing in async. It has Apache Kafka under the covers. So what you'll get back basically is you'll get back an ACK from the Kafka topic saying, yeah, I got your transaction. Here's a unique request ID that you can query downstream to see the status of this transaction. So what we'll do is we'll actually send this transaction in as async right here with our argument of 98, and then we'll query this unique ID downstream. So let's go ahead and fire that one in. And it comes back pretty much in real time, right? About 50, 100 milliseconds right here. And then what we can do is we can take this unique ID right here and we can query this guy downstream. So instead of calling /instances, we're going to call /replies right here and provide that unique ID that Kafka threw back to us, right? If we do this query too quickly before the transaction is actually mined, right, we're going to get a null response, right? So you just need to write some logic into your, into your server-side code to say, if null, then back off, retry, wait, 100 milliseconds, 500 milliseconds, et cetera, and then retry this call. So that's sort of the approach for synchronous versus asynchronous. Really, really straightforward. All you need to do, again, is just upload that source code into Kaleido. Cool. Okay, so I said we would do some stuff with tokens, and we will. So now let's hop down here to this digital assets section. Go ahead and click on our dashboard. And what I've done is I've deployed an ERC20 mintable and burnable token. And the cool thing in Kaleido is that you don't need to bring your own tokens. We provide token templates brought in from OpenZeppelin, obviously, where you can say, hey, I just want a vanilla ERC20, or I want a vanilla ERC721, or I want it to be mintable, or I want it to be mintable and burnable, right? And so what I've done is I've created an ERC20 right here with mintable and burnable characteristics. And I've applied the majority of the balance to node number 1 right here, his default account. So if I go ahead and select that account inside of the dashboard, I see that I have close to 1 million tokens right here. But what we can do, again, is we can use these REST APIs to do stuff with these tokens, right? So maybe I want to transfer some tokens to another recipient in the network, right? So this is the default Ethereum account on the other node inside of my environment, node number 2, 08166. So if we go to that node and take a look at it, we'll see that it has some allocation of this HLT token that I deployed, right? So we can go and view the details. We can view account details right here. We saw that it has no Ether balance from the Ether pool, but as soon as this loads right here, we'll see that it has a balance for this Hyperledger token and a balance of 200 right there. And what we can do with our APIs is we could say, hey, I want to transfer 100 more of these tokens from this holder, the guy that had close to 1 million tokens, and I want to send them to this other participant inside of the network, this identity. And these addresses can be anything, right? They can be in your MetaMask, they can be in an HD wallet, they could be held in a cloud HSM, right? This just needs to be a standard Ethereum hexadecimal string right here, right? So we can go ahead and fire this off right here, transfer 100 additional tokens. This is a synchronous call again, so it's going to wait for it to fully execute. There's the receipt. Came back in about 5 seconds, right? Proof of authority is 5-second intervals. And now we can just do a quick query. We can say, hey, Mr. Account, you just transferred 100 tokens. Your balance was 999,800. What's your current balance right now, right? That's what the balance was. It should be 100 less than that, and it is right here, right? And so the dashboard is really friendly, right? The dashboard is an admin utility, very easy to kind of like stand up resources and do some I guess, lightweight blockchain transactions. But obviously, as you're getting closer to building out an application, you want to get into Postman, then you want to start getting into, sort of Node.js or whatever your favorite language is on server code, and actually calling these REST APIs synchronously or asynchronously. Cool. Okay, pressing forward, let's look at another feature inside of Kaleido. And these are not Kaleido specific features, by the way. I don't want to make this sort of a Kaleido centric sort of webinar. They are encapsulated inside of Kaleido, but everything I'm showing you has actually been open sourced into a Hyperledger project called FireFly. So this REST API gateway, for example, that we call FabConnect, that is a FireFly project. This outbound portion of event streamings, this is part of FireFly. The ability to plug, different blockchain orchestrations, whether it's Besu, whether it's Geth, whether it's Fabric, right? Those are all encapsulated inside of FireFly. So let's take a peek at how events work inside of Kaleido. So for the folks that are familiar with Solidity and with event interfaces, it's really easy to define an event inside of your Solidity code, right? You just create that event object, and then when you have invocable functions that result in a state change, you can allow for that event to be emitted. And on Kaleido, as soon as you have uploaded your smart contract, we'll auto-index the availability of every signature, every event that you're allowed to subscribe to. And all you have to do is tell Kaleido where you want those to be delivered, right? So think of them being delivered to your application, but more closely the cloud architecture, think a Lambda function sitting behind the API gateway on AWS. And the takeaway of events is that you never have to query the blockchain for the current world state. You never have to do WebSocket polling on your nodes to start listening for events. But perhaps most valuable is you're going to have an off-chain local cache of all of the historical events and all of the current state information. So you can choose to automate logic and react to these events, but you also have that local database that will support hyper-efficient, super rich queries. So events are especially valuable. And let's take a look at how one of them looks. So from Postman, I was invoking my first node. I was invoking node number 1 with those transactions. So what we'll do is we'll go to node number 2, and we can prove that I was actually talking to node number 1, right? So here's the node ID, NEJI or JL right there. So if we go into the strings right here, we see that this is the specific node ID that I've been talking to. So what we want to do is we want to invoke this smart contract from node number 1, but we want to have node number 2 configure an event stream, execute this transaction, and emit an event, right? And so that's an example of, right, a multi-party system where you have different participants sending data into the network, right? Think supply chain, think healthcare, think trade finance, whatever, where different disparate participants need real-time notification of state changes that are happening in the network. So let's go to node number 2 and go ahead and create an event stream. So I will call this simple storage, since that's the smart contract that we're going to use. And I'm going to deliver it via webhook, but WebSockets are supported as well. I'm going to click next. And now Kaleido is saying, okay, cool. You've defined an event stream. Tell us where you want this data to be delivered. I'm not going to use an API gateway. I'm just going to use this free little subdomain service right here, request catcher. And here's the endpoint I'm going to use, ss123.requestcatcher.com/test. So that's what I'll teach Kaleido about right here. If you're doing this, in production, put a bearer token and protect these calls, obviously. So I'll click finish. And now Kaleido is saying, cool, you defined an event stream. Here's your unique event stream ID. And you've told us where you want it to go. Now tell us what data you're actually interested in. If we go back to the smart contract that we use, simple storage, we see that we have an event defined right here, right? And all this event is going to do is it's going to tell us what was the argument that we passed to this set method, right? What was the argument that we, declared the unsigned integer to be transitioned to. We'll get a bunch of additional rich information like the smart contract address, the transaction hash, block number, timestamp, etc. But specifically, we'll get the signature and we'll get the inputs right here, right? So we can think of this as, interesting financial information or state changes inside of supply chain, right? So we'll call our event for the description data stored. We'll choose a gateway API, right? We got to tell Kaleido, all right, where are you supposed to find this signature? We're going to go ahead and find it inside of that simple storage API. And now Kaleido is saying, oh, cool, here's that data stored event that you're interested in. So we can take all the events, we can take them from a specific block number, we can take them from all of the contracts that match the signature, or we can take them from a specific smart contract instance. So this gives you an idea of how you can, granularly scope these events, right, to different pipes and, sort of compartmentalize your logic. So I'll just say, hey, give me all the events right here. So we'll finish that, and that'll create the subscription. And then what we should be able to do is go back into Postman. We should be able to invoke the smart contract coming from node number 1. And then this event stream that's been configured on node number 2 should emit the event to this endpoint that we just configured. So let's give that a go, see if it works. So let's change this value down to 97 this time. Okay, so we'll fire this in. Let's fire it in synchronously this time. So we'll change this from false to true. And we'll fire away. And so if we're lucky, if we got this close enough to the new block interval, this can execute in 3 seconds. Sometimes if you're far enough away from the block interval, you'll miss a specific block and you may have to wait 6 or 7 seconds. So this took about 4.5 seconds for that to execute. If we go back to request catcher right here, we see that it ingested an event, right? So some interesting blockchain information around the number, around the transaction hash. But if we scroll to the end here, we see the signature that it matched, and then we see the inputs, right? And so this is like the real valuable piece, right? You're able to see, what was the smart contract logic, what was the method that was invoked, but what's the state change that, my business or my application actually cares about. And that's event streams in a nutshell. So sprinting forward, because I do want to show Fabric and I want to show a little bit of FireFly as well. Let's just take a peek at some of the other pieces inside of the dashboard. So we have a very rich block explorer where you can drill deep into specific transactions. So here's the one I just sent. We can see the method exposed right here. We can see the inputs. We can see who signed it, what smart contract it went to. If we're a system admin, we have rich, health and monitoring dashboards where we can, have scoped views of different resources, different runtimes across different intervals and different timeframes right here. We can dive into, one specific runtime, node number 1, for example, if we wanted, or we can see the macro view of the network. So just kind of like a really useful thing for, sysadmins, kind of like the root users of the system. If we go back up to the dashboard for our network, we can also see an audit log, right, of everything that's happened. So kind of like all of the interesting CRUD operations that have happened in the system. So, this becomes valuable when you truly decentralize your network and maybe you have, 6 or, a dozen different participants that are doing stuff in your network. You'd like to have, unequivocal, cohesive line of sight into what's actually happening inside of the system. Last thing we'll look at is we'll just take a look a little deeper onto a specific node right here. So we can go into the logs and we can see, kind of the core Besu logs right here. It's happily humming along, mining blocks, executing transactions, but we can switch the context here and we can actually see the REST API gateway logs. So this will show us transactions coming into the network, for example, and it'll show us event streams coming out of the network, right? So this is really useful for you to be able to potentially stream these logs right into CloudWatch or into some rich Kibana dashboard, for example, and you can make sense of what's happening on the Kaleido REST APIs versus what's happening at your application tier as well. Last thing with Besu or with many of the protocols under the umbrella is you can extend them and you can add your own sort of custom bespoke configurations. So we'll say just example config right here. Click next, and now we can see the default config parameters that we have, like the target gas limit and RPC cap. So we could arbitrarily inflate or deflate this, the same for the gas cap. We can choose if we wanted to run our node, as a full archive node. We can change the logging levels, et cetera. We can choose our tune our REST API gateway, et cetera. And these are, not binary choices. You can, add these configurations. You can remove these configurations. Same with the cloud configurations as well. So the system is, is flexible as you need it to be in the scope of your consortium and the scope of your application. Last thing I'll show you is this security tab right here. So this is what we needed in order for my Postman calls to successfully authenticate into Kaleido. And you do that via app creds. App creds are bound to a membership, just like your node was bound to a membership or a service was bound to a membership. Those need to have sort of a one-to-one correlation. right? So if I tried to call node number 1 with app creds from XYZ, that wouldn't work. If I tried to call node number 2 with app creds from ABC, that wouldn't work, right? So we can just say example creds right here, and we'll see sort of an ephemeral view of this username password. This is the only time you'll see the secret. So you either need to jot this down or you need to just regenerate the secret. Kaleido, obviously, for security reasons, doesn't persist this on your behalf. We do a salt hash verification. So this is the only thing we actually persist is the ID. Cool. Okay, let me hop a little closer into the world of FireFly now. So what I am going to show, if I can find the right tab here, is I'm going to show the same interface for speaking to Fabric. If I can find wherever I put it, I just want to show the architectural diagram super quickly. FireFly samples, FireFly FabConnect. Okay, so this is the open API specification for all of the APIs, the API surface of FabConnect. So dealing with the certificate authority, dealing with events, dealing with transactions. This is all open sourced under the Hyperledger umbrella. So you can go grab these APIs, chuck them into Swagger Hub or whatever your favorite, YAML conversion tool is, and you can program directly against these right here. I have a little cheat code in our dev environment where I'm going to use Swagger just for sort of ease of use inside of this demo. But every call that I'm making, everyone else can make as well. So let me switch context right here and we'll go into a different account. And I don't know if there's any questions, Karen, but do interrupt me if there's anything pressing.
Maybe it would be relevant to just pause here since you're switching into, using different networks. Someone, Kaleido here did ask about how they could connect their services to their website or use it for a marketplace. And if anyone else has questions while we pause here, let us know.
Yeah, I mean, I think it may be better to take that one offline, specifically with the whomever asked that question. But I think the takeaway is that, what I'm trying to show you with all of these services and all of these interfaces is that your existing systems of record, your existing e-commerce systems, your existing back office systems, you don't need to reinvent the wheel to be able to layer Kaleido and layer blockchain functionality into there, right? It's a simple integration with REST APIs, with hashing private data from your existing data stores, with using our event streams to ingest data from different participants inside of your network. So it really becomes a matter of, if you're creating a marketplace, sort of using blockchain as the beating heart of it, what are the assets that we're dealing with, right? Are we dealing with real world assets? Are we talking digital twins and NFTs of, actual, tangible constructs? Are we talking about tokens? Are we talking about, something else? So I think it's, not a black and white conversation. It really depends, specifically on the use case, on the requirements of the customer. But what I can say is, having worked, with, a wide variety of, huge enterprise customers in healthcare, in banking, in insurance, in retail, it's really, really a lightweight lift to, kind of extend the functionality of your existing systems with Kaleido and with whichever blockchain sort of orchestration that makes sense for your use case.
Couple questions related to what you just talked about as well. So Jose is asking if it works like a private blockchain where you can set gas. Can you set the gas to 0 if you want?
Yeah, so gas defaults to 0 by default. So we're talking about free transactions, right? Run 10 million transactions on Kaleido over the next 2 days. You're not paying for transactions. Our business is a SaaS business, so you pay for what you use, namely your nodes. So if your nodes are up and running, then you pay an hourly fee for those nodes. If your environment is paused, if your nodes are paused, you don't pay Kaleido anything. But you do have the ability to manipulate your blockchain, right? So if you do want to use that Ether pool and charge for transactions, you have that possibility, you have that availability to you. But by default, everything is gas price is 0.
Awesome, thank you. And then someone else has asked, do the configural parameters on protocol configurations of Hyperledger Besu have more options than Quorum?
I don't know that there's anything out of the box on Besu that Quorum doesn't have. Quorum has a private transaction manager, Besu has a private transaction manager. The majority of the parameters that we're talking about is sort of like the type of node you want to run, whether it's, full node, archive node, whether, you sort of want to up your logging level, info, debug, et cetera. But the real parameters you can tune are sort of like those gas prices and that RPC gas cap, which are the same defaults as Quorum and Besu. But if we looked a little deeper down onto those protocol configs, we could see that we could do some really, really valuable tuning right on that REST API gateway and on that underlying Kafka tier. But no, I think the answer to that question is they're more or less apples to apples, kind of on the protocol configs. Cool.
Thanks, Nick. That's it for now. So let's
keep going. Questions. Yeah, that's super. So what we're going to take a look at is the same interface, and we're going to talk to Fabric the easy way now. So what I showed you there was the whole footprint of FireFly projects under the Hyperledger umbrella. So there's at least half a dozen of those. And this is really similar to sort of what you just saw right here. But what this means is you don't need to have a client wallet. You don't need to do certificate signing requests going into a CA. You don't need to collect signatures for endorsement policies and be responsible for, reliably submitting transactions up to an ordering service or subscribing to events. Again, all of this is dealt with for you in Kaleido with Apache Kafka as the message bus. So let's just take a quick look at how easy this is to do with Fabric. So I have a web UI here, which I'll open real quickly. And what I've done is I've just deployed another fairly basic piece of chain code into this environment. So again, Hyperledger Explorer, okay, that's acting up. So we'll just skip that right there, but I was just going to show you that we have a chain code deployed. And what we're going to do is we're just going to go ahead and access this Kaleido Connect interface right here. So I need app credentials to do that. So I'll create some called ABC, and I'm just going to go to this endpoint right here, which should expose some accessible Swagger for me. Okay, it doesn't like the creds in the URL, so it just needs a refresh, and we're good. So I'm just going to go down the line here and do all of the logical steps inside of Fabric. We're going to register an identity. We're going to enroll an identity. We are going to invoke our smart contract and make a state change. We're going to query for the current status of, the assets inside of our smart contract. We're going to send something in asynchronously and grab the receipt, and then we're going to configure an event stream and subscribe to some type of subscription. So let's start by creating an identity in the system. So I'll create one for user 2, and we'll enroll him as a client. So click execute, and I'll be returned the secret right here. So I can grab this secret, and then I can do the enroll call. So we'll post to this enroll endpoint right here. So we'll say, try it out, user 2, provide the secret, and we'll go ahead and enroll this guy. And then what we can do is we can actually query this user. We get back the 200 response, and we'll be able to see the enrollment certificate, and we'll be able to see the CA certificate, and all those otherwise terribly unpleasant things that you have to do with certificate signing requests and dealing with certificate authorities. So this was all of 2 API calls, which took, probably 8 total lines of JSON right there to properly enroll a user. And this sort of embeds your wallet, your client identity too. So you don't have to worry about signing. You don't have to worry about, endorsement collection. Again, all of this is encapsulated robustly inside of this layer. So what I have inside of my network is I've deployed this asset transfer basic chain code. So what I did is I just compiled the Go binary for this chain code. I uploaded it into the smart contract management system on Kaleido, and I pressed a couple buttons and it deployed it into my environment. It instantiated that smart contract. Again, that's also backed by a REST API, just like Ethereum. So what we're going to do is we're going to invoke this smart contract, and we're going to call this create asset method right here. So back to Swagger, and let's open transactions right here. So we're going to say send transaction. The signer is going to be user 2. The channel is going to be the default channel that Kaleido created for free for us. So you don't even have to bother creating a channel in Kaleido either, right? We'll do the bootstrapping of the default channel for you by default, so that you just have a ready-to-use channel to, deploy chain code onto and immediately send transactions into the network. So I named my chain code package asset transfer. So I have 2 T's right there, and our function is going to be create asset right here. So we need to give it some args, which I have on my notepad, if I can find that. So we want to give it some args that look like this right here. And we can fire this in. So I need to actually change these quotes. They did the prettified quotes. And let's make this more interesting. Whoops, I need to put the quote right here. So we'll make this blue. We'll give it a size of 1. We'll give it to myself since I'm doing the demo, and we'll give it a value of 100 right here. So we can fire this in. And again, this came in synchronously right here. So we see the transaction receipt, and now we see the transaction ID, which we can track downstream. So let's go ahead and do that. So we'll grab this transaction ID right here. Let's close up this method, and let's go ahead and say, hey, tell me some more details about this transaction. So I'm going to give it the transaction ID, tell it what channel it's supposed to come from, default channel, and who signed that transaction, user 2. So we can go and say that, and now we see some more rich information, right? We see the full object of the body, we can see the proposal hash, the name of the cheat code I invoked, etc. Okay, so that was a synchronous one, and as you can imagine, we can do this just as easily asynchronously. So let's send this in false. Let's change this to asset02. We'll change it to purple. And we'll give it to Karen. And since Karen's special, we'll make it worth 1,000. So we can execute that, and immediately it returns, right? It's just this fire and forget, more or less, to that Kafka topic. So we can take this receipt ID right here, and similar to ETHConnect, we'll just call the receipts endpoint. So we can go to get receipts ID, click try it out, give it that receipt ID, and this will return us the transaction ID, which in turn we can go and call that transaction ID endpoint, and we'll see all that information about Karen's new asset that we just created. So finally, we can just overwrite this right here, click execute, and we'll see the new asset that we just created, asset 02, which is purple. Super. Okay, so 1051, we're doing okay. Let's press forward and let's create an event stream for Fabric. So just like we did on Ethereum, we just need to tell Kaleido where we want this data to be delivered. So I'm going to say try it out. We'll just say example. I'm going to go with webhooks instead of WebSockets. So I won't bore you with the command line. We'll say webhook. And now we need to say the URL, and we need to tell it where it's going. So I'm going to use this webhook.site right here, which will take in all of my requests. So we have a bunch of transactions that have actually taken place inside of the network, mainly being system transactions, but we do have 2 interesting asset transfer transactions, the one I created for myself and the one I just created for Karen. So we're going to copy this endpoint to our clipboard and go back to Swagger, and we're going to tell Kaleido that this is where we would like our JSON payloads to be distributed, right? And then we're going to say TLS skip verify host is true, just for simplicity. Okay, so that all looks good. We can define this event stream object right here, and now we have this. So this is the actual event stream that Kaleido knows about, and this is what we're going to tell our subscription about, right? This will redirect all the way into that endpoint that we defined right here, this webhook.site. So let's grab this event stream resource ID, and let's go create a subscription. We'll click try it out. I'll just say asset transfer subscription. We're going to give it that stream ID. We're going to give it the default channel. We're going to give it user 1 or user 2 rather. We're going to go from block 0. We're going to say the payload type is stringified JSON. And we're going to skip the chain code ID and the event filter. I don't have events defined inside of that chain code. But if you want your events to be a bit more granular and a bit more, I guess, ingestible, I'd encourage you to define these chain code IDs and that event filter as well. So we can just go ahead and click execute right here. That should be happy. And now if we see my webhook.site right here, we see a bunch of stuff's happening, right? It was sitting at 0, and now we have 5 transactions that came through. So again, a lot of these are the system transactions, but if we go to the most recent one right here, and we actually take that transaction ID, we can go query that on Kaleido, and this should be the most recent asset that was created for Karen. So if we go back to the transaction IDs right here, and overwrite this, we should see that that's the actual same asset or transaction ID. So we look at this and that it was Karen's asset. And again, that would have made a bit more sense if it had been defined with an event and defined with a chain code ID as well. So that's FabConnect in a nutshell. And if I have, Karen, do I have 3 or 4 more minutes? I can show FireFly super quickly.
Yeah, please do.
Cool. Okay, so let's take a look at FireFly then. This stuff is amazing, and there's actually a community call happening in 5 minutes. So I'm going to paste this in the chat. This is just a link to the FireFly wiki where you have the calendar that's available. So there's some really cool stuff happening today around token interfaces and around on-chain logic and a lot of extensions into the FireFly community. So if any of this was, even, had a modicum of interesting information, I'd encourage you to, join these bi-weekly community calls with, the engineers that actually built the guts of this system, right? I'm just a talking head that knows how to press a couple buttons, but these are the true subject matter experts that, if you have low level, networking or interface questions or want to contribute to this community, hint, hint, this is a fantastic place to sort of engage and interact with, other FireFly folks and a bunch of people on the Kaleido team. And as I mentioned, there's a huge footprint of FireFly repositories, many of which would love you to give them a star if you're able to use any of these. So let's just take a look at how it works. So what I'm going to do is I'm going to create my own FireFly stack, right? And this is heavily documented if you just go to the FireFly docs. So I'm just going to say FireFly init. This is how you create a new stack. And I'm going to make one called data transfer right here. It's going to say, hey, Nick, how many members do you want? Well, I want to show private transactions. I want to show off-chain private messaging. So I'm going to create 3 members right here. Okay, so it's saying, okay, cool. Now I understand this. I have a Docker Compose that I'm ready to stand up. Go ahead and say start this stack. So I'm going to say ff start data transfer right here. And this will take about a minute or so for this to come up. But what we'll see inside of FireFly is we'll see the ability to do a lot of high-level things that proxy down into the blockchain layer. So a lot of the things that get pinned onto the blockchain in FireFly are simply just references to hashes, right? The number of hashes inside of the system is probably layered like 3 or 4. Maybe even 5 layers deep, right? So you have a lot of this nested logic and a lot of, sort of elegant wrappers, with messages, with transactions, with data attachments, with unique IDs for, everything that stays off chain. And then you just pin references of this data onto the blockchain. And you have all of those rich interfaces that I showed you, ETH-Connect, FabConnect, the ability to ingest events, the ability to subscribe to events. You have the ability to publish data to all of the network or say, hey, we have a network with, Nick, Kevin, Karen, Tomas, etc. I just want to do a private data transfer from Nick to Karen right here. And we'll put, an indecipherable message of that onto the blockchain that is proof of that transfer, but that no one else can decrypt or make sense of. So we'll show you that, and I'll show you kind of a very, very easy to use bootstrapped application that's also open sourced in the FireFly samples, which will expose a user interface, allow us to sort of toggle through the different participant views and choose if we want to, send public data or if we want to send private data as well. So we can see that FireFly is coming along right here. It's unlocking the smart contracts. It's writing those, data exchange certs so that we can have encrypted transport of our private messages. And as soon as this is almost ready, I can hear my fans humming right now. It's going to expose the localhost ports for us to access, right? So we see I can go to 5000, 5001, and 5002 right here. So while those are up, let's go ahead and kick off this application right here too. So I'll just say npm start. And this guy will take about a minute too. So while that's coming up, let's go ahead and open up some of these user interfaces. So we can go to localhost 5000 UI right here. Here we see the FireFly dashboard. We can go to localhost 5001. We don't want 3000. That's the application that's trying to open up. 5001/UI. And we can go to 5002/UI. What we'll do is we will send a private transaction using this application from org 0 to org 1, and we'll prove that this org right here, org 2, is not going to have any line of sight into that transaction. So pretty straightforward. So let's go back here. This guy's up and running. So let's open localhost 3000 and get after it. So let's go to 3000. Boom. Okay, so first let's just send a message to the whole network. Say hello world right here. Okay, so all of these organizations are going to get this network. A hash of that's going to get pinned onto the blockchain right there. Hello world, right? So we can go, that was sent from org number 0 right here, localhost 5000. So we can go to this guy, the third org in our system, go to the data explorer right here, go to the messages and see that, hey, he got a broadcast message right here. We can click on it. We can see that, hey, hello world. And this hash right here, 99 or 9DDE right there, we went into some sort of, SHA emulator right here, we would see that that's the exact same hash that we have, right? This hello world right there, 9DD right there. So that's the hash of that. Okay, so pretty straightforward. Let's go ahead and send a private transaction now. And again, conscious that we're at the top of the hour, but this is pretty cool. So I'll just say private info right here. And we're going to send it from org 0 right here to org number 1. Org number 2 is not going to have any line of sight. So that will come back in. Here we see the message right here, private info. We can go to org number 2 or org number 1, sorry. We have 0, 1, and 2. So I'm missing some of these. So go to the data explorer again. We can go in here and see that he has 2 transactions and 3 messages. The first message right here is defining the group, right? So this is saying like, hey, this is you, this is org number 1 right here, this is your identity, and this is org number 2 right here. So if we click on this guy right here, we can see sort of this JSON object of who's inside of this system of this private message right here, right? This is org 0 and this is org 1 right here. We go into the second data attachment right here, we can actually see the private information. And now if we go to org 3, we go back to its dashboard, we'll see that it does have 2 transactions, right? It has a reference of that transaction that we just sent into the network right there, but it can't make any sense of it. All it knows is the identity of the node that sent it into the network, right? But if we go back to org number 2 right here, or org number 1 or org number 0, then we have full line of sight sort of into that private message and into that transaction as well. So that gives you an idea sort of how FireFly works. You have a network map view right here that's pretty useful to see organizations. You can find the associated Ethereum account that's associated with that org identity, right? So if we looked at that transaction when we saw who it was from, A4A right there, that was actually org 0's organization, right? So if we go to that transaction, we click on it, it came from A4A, which was org 0. So that was a whirlwind tour, conscious that I gave you guys a lot of information, but I hope the majority of it was interesting. This is all, again, everything I did, you can do yourself. It's documented. There's a ton of videos that I've recorded out on the Kaleido YouTube. Our team is accessible, via our product and via the FireFly community. We would love for everyone to get involved and be, as active and participative as you can possibly be. And we're, here with open doors and here to help and just want to grow the community and build cool technology. So really appreciate everyone attending and staying for the full hour. Appreciate Karen and the Hyperledger team for the time to share some information today. And a sincere thank you from me to everyone.
Thank you, Nick. This was wonderful. You went through so much information. A lot of it is so helpful for all kinds of use cases where people are trying to use different protocols, trying to do private transactions. So very, very helpful. Appreciate your time. Thank you so much. And anyone, if you want more information, please feel free to reach out to us or reach out to the Kaleido team. Just have a couple of things to share with you before we finish today. We do have more webinars coming up, so stay up to date on our events page. More immediately, though, we have a workshop. This is actually several hours long, so really goes into a deep dive into Hyperledger In-depth. So if you're looking to do anything in digital identity, learn more about how to use Hyperledger In-depth, we highly recommend this. It's going to be a very interesting session. Please get involved. There's many ways in which you can do that. Attending more of our events, checking out our wiki or our website, joining our many community groups that talk about use cases or talk about our different projects and technologies. Thank you so much for watching and for joining us today. Thank you to Nick and the Kaleido team as well. And please have a wonderful day. Stay safe.
And join the FireFly call. It's happening now.
Yes, I posted the link in all the chats. So if you want to dive in immediately into FireFly, it is happening right now, and we welcome you to join. Thank you, everybody. Have a great day.